Good morning, everyone. In this session, we are going to discuss about the Navy Bayes classifier. Last class, we discussed about Bayes theorem. This is the continuation of that Bayes theorem, that is Navy Bayes classifier. So, what is this Navy Bayes? Navy Bayes is a simple but surprisingly powerful algorithm for predictive modeling, and of course, it is a classification technique and it comes under supervised machine learning. Here in Navy Bayes, we need to discuss about two terminologies, that is, what is this Navy and what is this Bayes. We already know this Bayes theorem, so it is derived from Bayes theorem. That's why one name was Bayes. But what is this Navy? What is a new thing in this Navy Bayes algorithm compared to the Bayes theorem? It is a classification technique based on Bayes theorem with an independent assumption among predictors. So in simple terms, we can say that a Navy Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. That is, if you take a particular sub features, if it is round, color is red, and the shape is spherical, then we can say that that fruit particular belongs to the red. Even though these all features are dependent on one another, Navy Bayes treats that those features are independent assumption. That is what the Navy. That's why then this classifier is called as a Navy Bayes classifier, and it is a popular supervised machine learning algorithm used for classification tasks such as text classification. This approach is based on the assumption that the features of input data are conditionally independent given the class and allowing the algorithm to make predictions quickly and accurately. That itself make the algorithm which it treats that it is independent of each e class. So that's what the algorithm make predictions quickly and accurate. In statistics, generally these Navy Bayes classifiers are considered as simple probabilistic classifiers. Why? Because it is going to apply the Bayes theorem. And we know that this theorem is based on probability of a hypothesis given the data and some prior knowledge. Yes, of course, some prior knowledge is been given and a hypothesis is given. We have to find out the probability. And this classifier assumes that all features in the input data are independent of each other. But actually, which is often not true in real world scenarios. Okay. Despite this simplifying assumption, the Navy Bayes classifier is widely used because of its efficiency and it gives us good performance in many real world applications. For example, as I told earlier, if a fruit is to be considered apple, when we consider it as apple, the color should be red and the shape should be round and size maybe 3 inches in diameter. Even if these features depend on each other or upon the existence of other features, all of these properties independently contribute to the probability that this fruit is an apple. That's why it is known as name. Think like it's a new assumption. And this Navy Bayes model is used to build and particularly useful for very large data set. If the data set is large, okay, we can easily build this Navy Bayes model quickly. And along with simplicity, it is known to be outperform even highly sophisticated classification methods. These are what are some advantages of using this Navy Bayes. But how do this Navy Bayes algorithm works? Okay, we need to follow some steps to construct a Navy Bayes algorithm. The very first step is convert the data set into a frequency table. So when you consider, suppose this is the given data set with two attributes, if weather is sunny, yes, we want to play some game. No. If weather is overcast, yes, if we want to play some game, yes. Like that, a simple data set is here. So very first step in Navy Bayes algorithm is we have to convert it into frequency table. This one. Okay, I'll explain this example further. How we are going to write all these values. That is the very first step. Then the second step is create likelihood table by finding the probabilities. Yes, we have to find out the likelihood table by finding the probabilities. Like, see here something we have written the probability of overcast, probability of rain, and the probability of playing yes, playing no. So how we are going to find out this? We'll discuss that. So this is what the next step, we have to create the likelihood table by finding the probabilities. And now we have to use Navy Bayes equation to calculate the posterior probability. We already know that the this one Bayes theorem, probability of A given B equal to probability of B given A into probability of A divided by probability of B. The extension to this is the Navy Bayes. So we are going to use this equation to calculate the posterior probability. Okay, and the class with the highest posterior probability is the outcome of the prediction. Okay, these are the main three steps. One is from data set construct the frequency table. Then the second one is we have to calculate the likelihood of the probability of each outcome. And then last step is we are going to use the Navy Bayes equation to calculate the posterior probability. And coming to this construction of a Navy Bayes, we can construct with the help of three methods. One is Gaussian Navy Bayes, one is multinomial Navy Bayes, and other one is the Bernoulli Navy Bayes. Mostly we are going to use this Gaussian Navy Bayes for finding such frequencies and likelihood of the table. Now, where is Navy Bayes used? What are the applications? What real world applications we can use this Navy Bayes? One is the face recognition, one is weather prediction, and then medical diagnosis, whether a particular person is having some disease or not, and news classification, and then spam filtering. Even for spam filtering also we can use this Navy Bayes, and news categorization like into different things, and object and face recognition. So these are all of the some of the applications of this Navy Bayes algorithm. Now let us construct one example of this Navy Bayes algorithm. As I told earlier, there will be three steps. Let us, with the help of those three steps, let us construct. First, this is the given data set with three attributes and one class label, that is no yes or no. This is a class label, and these are the three attributes: outlook, humidity, and wind. So now with this, we have to find out the probability whether some condition is given, that particular person is going to play or not, yes or no. Okay, for that, the very first step is, given the data set, we have to convert it into the frequency table. Yes. Now, see here the frequency table. See, for each attribute, outlook, humidity, and wind, we have to construct the frequency table. And when you take this outlook, you see we have 14 rows. Okay. When we take outlook, we have three values in that outlook. When this you take our outlook attribute is, we have three values. One is sunny, overcast, and red. And coming to the sunny, just count how many values are there sunny. 1, 2, 3, 4, 5. Total 5 sunny values are there. In these 5 sunny values, check for how many yes, how many no. So 1, 2, 3. 3 no are there and 2 yes are there. Okay, so now sunny yes equal to 2. Here some wrong, it is wrong. You just modify these values. And no is 3. Okay, see 1, 2, 3 no's are there and 2 yes are there, and total we have 5 sunny values. So 2 plus 3, 5. Now coming to the next value, overcast. So see here how many overcast is there. 1, 2, 3, 4. And in this overcast, how many yes, how many no, we'll see. 1 yes, 2 yes, 3 yes, 4 yes. And only 4 yes are there. There is no, is 0. So it is 4 and it is 0. Similarly, for rain, you see how many are there. 1, 2, 3, 4, 5. Total 5 rain values are there. In this 5 rain, let us see how many yes are there, how many no are there. So it is 1, 2, 3, and 1, 2. Yes, 3 yes are there and 2 no are there. In this way, for each and every attribute and its corresponding values, we have to construct the frequency table. And we have two class labels, yes and no. Okay. For how many yes for that particular value, that we have to make a note in this table. This is how we are going to construct the frequency table. Similarly, check for this humidity. In humidity, we have high and normal. And check how many yes are there and how many no are there for high. And similarly, for how many yes are there for normal and how many no are there for normal, and construct the frequency table. Similarly, for wind. Wind, we have weak, strong. We have only two values in this wind. And check how many yes for weak, how many no for weak, and how many yes for strong, and how many no for strong. Like this, I have constructed the three frequency table. Okay, this is the very first step in the Navy base algorithm. Next one, the classification steps. Okay. Now, next one is finding out the probabilities, likelihood of the probabilities. Now, we have to find out the probabilities of this one. That is, see, let us construct this one. So here, I'm writing here, sunny, overcast, rainy. And it is, one is yes, one is no. Okay. We, as per this, we know that it is 2, 3, and it is 4032, 4032. This is the frequency table. Now we have to find out the likelihood of the probabilities. Now see, in this, a total of how many yes we have in this particular uh, data set. Check for how many yes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have total yes. If it is 9 yes means remaining are 5 no. So now what we are going to do is, so total out of 9 yes it is 2. Out of 5 it is 3. Similarly 4 by 9, 0 by 5, and 3 by 9 it is 2 by 5. Now, this is the probability of yes, and this is the probability of no. Okay. This is the second step what we are going to do. Okay. Now, construct the probability of this. What is the attribute here we are taking? Outlook. Now, the outlook total yes is, count here, 2 plus 4 plus 3, that is 9, divided by how many values are there? We have total 14 values are there. So this is the probability of yes for the outlook. Similarly, probability of no, check 3 by 2, it is 5. And total of how many class labels we have? It is 14. Okay. Similarly, let us construct for each and every value. If it is sunny or overcast or rain, how we are going to find out, check here. So it is total 2 plus 3, 5. And we have total class labels as 14. Then 4 plus 0, 4. We have class labels 14. Similarly, 3 plus 2, 5. And total class labels is 14. Okay. Now, we have to find out an equation of likelihood of yes given sunny. The question here is likelihood of yes given sunny, and similarly we have to find out likelihood of no given sunny is. Okay. So I'll explain you clearly this example, this table. So remaining, you only try to find out this one. Okay. Now we have to find out the likelihood of yes given sunny. Okay. Given sunny. Now probability of sunny given yes is equal to, so how many are there? It is 2. 2 is there. Probability of sunny given S is 2 by 9. That is, if you calculate, you are going to get it as 0.22. That is this one. Probability of sunny given yes. Okay. Next one is, what is the probability of sunny? Probability of sunny is total, it is given by this one. This is probability of sunny. That is If you calculate 5 by 14, you are going to get it as 0.36. Then the probability of yes. Okay. Now probability of yes is given by 9 by 14, which is equal to 0.64. That means, what is the formula? Probability of yes given Sunny equal to probability of given Sunny equal to probability of Sunny given yes into probability of yes divided by probability of Sunny. Okay. So this is the formula as per our base theorem. Now probability of Sunny given s equal to 0.22 into probability of s equal to 0.64 divided by probability of Sunny equal to 0.36. So we'll get it answer as 0.61. Okay, just calculate and you'll get answer as 61 or 64. Okay. Now similarly, we have to find out probability of no given Sunny. Okay. Now probability of no given Sunny. So how we are going to find out probability of no given Sunny? It is probability of Sunny given no into probability of no divided by probability of Sunny. So probability of Sunny given no is given by this value, that is 3 by 5 into what is the probability of no? What is the probability of no? It is 5 by 14. 5 by 14 divided by what is the probability of Sunny? As we find out already here, it is 5 by 14. That is same value. 5 by 14. Now when you multiply, you are going to get it as 0.6, 0.36 divided by 0.36. You'll get something value as 0.6. So this is the probability of yes given Sunny and this is the probability of no given Sunny. Okay. In this way, similarly, find out for my question here is similarly find out here for humidity, high and normal, okay, for wind and okay, for only high, for humidity you find only for high and for wind only you find weak. Okay, and check the answers whether you have got the same or not. Cross check the values. If any values are here, some mistakes are there, you rewrite the table and find out whether these answers are correct or not. And this is the way how we are going to find out the likelihood for humidity. And for humidity, we will calculate only high. And for likelihood table for wind, just calculate only for weak. Now, after calculating this, my question is, the condition given is outlook equal to rain, humidity equal to high, and wind equal to weak. Then the question here is whether we can play or not. If these are the attributes given, then we can play or not, whether we can no or yes. Now, how we are going to find out that values? So how we are going to, the question is outlook equal to rain, humidity equal to high, wind equal to weak, play equal to yes or no. So for that, how we are going to find out that one? So it is the likelihood of yes is given as probability of outlook equal to what they have given, outlook equal to rain. Rain given yes. Why? Because we are finding the likelihood of yes. Okay. Into probability of humidity equal to, what is the humidity they have given? High. humidity is high, given yes, multiplied by probability of wind given weak given S into probability of yes. Okay. So we already know all these values as in the frequency table, and in likelihood of all these likelihood, when we find out the likelihood tables of this uh, outlook, humidity and wind, from there, okay, find these values. Probability of rain equal to yes, humidity equal to high, and this one, just substitute all these values into this one. You will get it as probability of outlook equal to high and rain, and yes, it is 0.33, or whatever the values what we have find out earlier. Those values just you place here, that it is 2 by 9. Directly will have values here. 2 by 9 into humidity equal to high, given S is 3 by 9, into probability of wind equal to weak, given S is 6 by 9, into probability of S is total we have 9 S out of 14. Okay. So the value is 0.0199. Okay. So here you can see here it is 0.0199. Okay. Now, after this, similarly, find out for no. Okay. So, no probability of outlook equal to rain, given no, into probability of humidity equal to high, given no, into probability of wind equal to weak, given no, into probability of no. Okay. So, when you place these values, we will get 0.0166. Okay. 0.06. In this way, we are going to find out the values, how find out these values of likelihood and frequency. And here we are going to find out the what is the probability to play or not. And coming to here, the last step, what is the probability of yes? Probability of yes is given by probability of yes divided by yes plus no. Probability of no is given by no divided by yes plus no. Okay. So when you calculate this, whichever is having highest value. So when we calculated this, probability of yes is having the highest value, that is 0.55. So we can say that then what is the play equal to, we can conclude that yes. Okay, why? Because we have this, and when you add this, it should be equal to 1. That is what the Navy base classifier. Okay, the formula is probability of S equal to probability of S given by S plus no, and probability of no equal to no divided by S plus no. And when you add this, it should be equal to 1. Then we can say that what we have predicted, the answer is correct. So if we have S is having the highest probability, then as per the given condition, when outlook equal to rain and humidity equal to high, wind equal to weak, yes, play equal to, the answer is yes. In this way, we are going to construct a Navy-based algorithm for a given data set. Thank you.